Hi, I'm Oluwakemi. I'm excited to have you here again. This is JAMB Physics 2018 question 1, which goes thus. A galvanometer of internal resistance 50 ohms has a full-scale deflection for a current of 5 milliampere. What is the resistance required to convert it to a voltmeter with full-scale deflection of 10 volts? To measure the maximum voltage by the voltmeter, the high resistance R is connected in series, and so the voltmeter is equal to the current deflected in the galvanometer, okay, multiplied by the addition of the high resistance plus the internal resistance R. The high resistance capital R, the small resistance small r. Okay, and in this case we have V equals to 10 volt as given in the question. Okay, also we have the capital R, which is the resistance. Okay, we are looking, that is exactly what we're looking for. We also have the I, the current deflected in the galvanometer. We have the 5 milliampere. For 1000 milliampere is equal to 1 ampere. Okay, which means that 5 milliampere will be equal to 1000 divided by 5, and that will give us 0.005 ampere. Alright, we're also given the resistance of the galvanometer, small r, which is equal to 50 ohms. Okay, good. So now we're going to input these values in the given equation. So for volt we have 10 equals the I as given 0.005 brackets R plus 50 ohms. Alright, next we need to divide both sides of the equation by 0.005 in order to eliminate it from the left hand side. Okay, so this cancel this out. 10 divided by 0.005 will give us 2000 equals R plus 50. So if we subtract 50 from both sides of the equation, we have R equals 2000 minus 50, and that will give us 1950 ohms. Okay, and that goes with the answer option B. So answer option B is the correct answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 2, JAMB Physics 2018, which goes thus. If x times 10 raised to the power minus 2 joule of work is required to move 100 microcoulomb of charge from a point X to a point Y in an electrical circuit, the potential difference between X and Y is, the potential difference is the work done per unit charge, which is V equals W over Q. V here is the potential difference in volt, while W is the work done or energy transferred in joules, while the Q is the charge in coulombs C. Okay, so let us try to input the values as given in the question. V, which is the potential difference in volt, is exactly what we're looking for. That is unknown. Okay, while W, the work done as given in the question, is this. So we have 8 times 10 raised to the power minus 2, okay, to be divided by the column. Remember that the column we're given is 100 microcoulomb, okay, and 1 millionth microcoulomb is equal to 1 coulomb. Therefore, 100 microcoulomb will be equal to 1 millionth of this divided by 100, and that will give us 10 raised to power minus 4. That is to divide this by 1 million. Okay, good. So we have Q as 10 raised to power minus 4. So let us simplify further. So V equals 8 times 10 raised to power minus 2. In indices, if we bring this 10 raised to power minus 4 up, we have 10 raised to power 4. Okay, so we simplify further. So we have V equals 8 times this, and indices would be 10 raised to power minus 2 plus 4, and this will give us the final answer. 8 times 10 raised to power minus 2 plus 4 will give us 2. So the final answer, the potential difference between x and y, is equal to 8 times 10 raised to power 2 volts. And the answer option C seems to be the right answer. So this is the correct answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Olu Kemi. I'm excited to have you here again. This is question 3, JAMB Physics 2018, which goes thus. In a meter bridge experiment, 2 resistors, 2 ohms and 3 ohms occupy the left and right gaps respectively. Find the balance point from the left side of the bridge. A meter bridge is used in finding the unknown resistance of a conductor as that of in a Wheatstone bridge. Okay, and the Wheatstone principle states that the resistance on the left, the ratio of the resistance of the left to the ratio of the resistance to the right is equal to the length to the left over the meter rule. The meter rule is 100 minus the length to the left. Okay, good. So now we're going to substitute the values. The ohms, that is the resistance to the left, we're given is 2 ohms. So we have 2 over the resistance to the left, that is 3, okay, equals L bracket 100 minus L. Okay, so now we cross multiply. So we have 3L equals 2 times 100 minus L. We have to open the bracket now. So we have 3, we have 3L equals 2 times 100. We have 200. Then minus 2L. So now if we collect the like terms, on the right hand side we bring 2L. So we have 3L plus 2L equals 200. Okay, so 3L plus 2L will give us 5L equals 200. So now we have to go ahead to divide both sides by 5. So these cancel this out. Okay, then 5 and 200 will give us 40. Okay, so the length to the left is 40 centimeter. So the answer option B is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm excited to have you here again. I'm Oluwakemi, and this is question 4, JAMB Physics 2018, which goes thus. 250 microfarad parallel plate capacitors are connected in series. The combined capacitor is then connected across a 10-volt battery. The charge on each plate of the capacitor is, remember that the capacitors are connected in series, and so to find the total capacitance, which is 1 over C, equal to 1 over the first capacitor plus 1 over the second capacitor, and this is going to give us 1 over C equals 1 over 50. Remember, we're given as 50 microfarads. Okay, so now we're going to have, since we have in the fractions we have the same denominator, we're just going to add the numerators together. So we have 1 plus 1, which will give us 2. So we can go ahead to divide. So we have 1 over 25, and then simplify further. We have C, that is, if we cross multiply, we have C equals 25. And remember, take note that we've been doing this in the microfarad units, which we need to convert to farads. And for the microfarad, we're talking of 1 millionth microfarad will give us 1 farad. Okay, and that means that we're going to divide 25 microfarad by 1 million, okay? So we have 25 times 10 raised to power minus 6, okay? So minus 6 farad. So this is the capacitance. So now we need to calculate the charge stored in a capacitor, which is equal to, the charge is Q, which is equal to the capacitance C times the volts applied to it. And with this, we already have the capacitance, which is this 25 times 10 raised to the power minus 6, to multiply the volts applied, which is 100. So we have 100. Okay, so if we simplify further, we have 25 times 10 raised to the power minus 6. Then this is 10 raised to the power 2. So in indices we now have plus 4, and this is going to give us 2, that's 25 times 10 raised to the power minus 4. And if we leave this in indices form, we're going to have 2.5 times 10 raised to the power minus 3 column. Okay, so if we check the answer options, the right answer option is B. Good. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 5, JAMB Physics 2018, which goes thus. What is the total electrical energy consumed by using an electric cooker rated 1000 watts for 5 hours? The electrical energy equation or formula is equal to E equals the power, which is measured in watts, times the time T, which is measured in seconds. Okay, so now if we go back to the question, we will see that the power given, which is in watt, is 1000, okay, times the time given, which is in hours, and that is 5. So we need to convert that to seconds. So we have 5 times 60 times 60. Okay, good. So now we can quickly use our calculator to multiply this. So we have 1000 times 5 times 60 times 60, and that will give us 18 million. Okay, so we have 18 million, and if we're to leave that in indices form, we'll have 1.8 times 10 raised to the power what? Okay, let us count. 1, 2, 3, 4, 5, 6, 7. 10 raised to the power 7 joules. Okay, good. So now let us check the answer option. Answer option C is the right answer. Good. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Kemi. I'm excited to have you here again. This is question 6, JAMB Physics 2018, which goes thus. The power dissipated in an AC circuit with an RMS current of 5 amps, RMS voltage of 10 volts, and a phase angle of 60 degrees is the power represented with the letter P, is equal to V times current. V is voltage, I is current, cos theta. Okay, the V and I are sinusoidal RMS values. Okay, while the theta is the phase angle between the voltage and the current. Alright, so now let us solve for the power. Alright, so we're going to input the value. The volt as given is 10 volts. The volt as given in the question is 10 volts times the current, which is given as 5 amps, then times the cos theta, which is given as 60 degrees. Okay, good. So we simplify further. We have 10 times 5, that's 50. Then cos 60 is 1 over 2. And this is going to give us final answer. 2 goes in here, 1, 2 in there is 25. So power is 25 watt. Okay, so if we check the answer options, answer option A is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Kemi, and this is question 7, JAMB Physics 2018, and the question goes thus. The voltage of the domestic electric supply is represented by the equation. This given equation determine the frequency of the AC supply if you're given pi as equal to this. Okay, so let us write out the equation that was given in the question. V equals 311 sine 314.2 t. There are some basic values that we need to identify in this given equation. Okay, alright, so for 311 it represents amplitude A. Okay, for 314.2 this represents angular frequency, and from this angular frequency is equal to 2 pi, which represents radian, times frequency. Okay, so if we now make F the subject of the formula, that is, we have F equals angular frequency divided by 2 pi. Okay, alright, so now we can substitute the value for the angular frequency given here in the equation. We have 314.2 to be divided by 2 times the pi given in the question, 3.142. Okay, let us quickly use our calculator to get this. Sorry, let me bring that out. So we have 314.2 to be divided by 2 times this, we're going to have 6.284. Good. So this is going to give us 50 hertz. Okay, good. So the answer option A is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 8, JAMB Physics 2018, which goes thus. In a purely inductive circuit, the current. First, let us take a look at pure inductive circuit. The circuit which contains only inductance, that is L, and not any other quantities like resistance and capacitance in the circuit, is what is called pure inductive circuit. Let us take a look at what this circuit looks like in the diagram. So I'm going to make a quick diagram of the pure inductive circuit. So this is what the pure inductive circuit looks like. And in this type of circuit, the current lags behind the voltage by an angle of 90 degrees. Okay, so let's take a look at the options. In a purely inductive circuit, the current A lags behind the voltage in phase by 90 degrees exactly. So the answer option A is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 9, JAMB Physics 2018, which goes thus. One of the features of the fusion process is that, first let us take a look at the meaning of fusion before we go into the given option. So in nuclear physics or chemistry, nuclear fusion is a nuclear reaction or radioactive decay process in which the nucleus of an atom splits into smaller or lighter nuclei. Okay, that is, let me write that, nuclei. Alright, so now that we know what fission is, let us go to see what the options have to say. Option A says its products are not radioactive. The fission fragments are highly unstable. Highly unstable because of the abnormally large number of neutrons compared with protons. Consequently, they undergo successive radioactive decay. So this answer option is not correct. Okay, answer option B, it leads to chain reaction. If one fission, I'm just using F, reaction produces two neutrons, these two neutrons can cause two additional neutrons. And if these two neutrons releases, we have 4 other neutrons. Okay, and so on, leading to what is called nuclear chain reaction. Okay, so this option is a feature of the fission process. Okay, let's take a look at option C, which says neutrons are not released. As we said earlier, one fusion reaction produces two neutrons. So neutrons is one of the products or the fragment of fission. So this answer option is incorrect. Alright, let's take a look at option D. The sum of the masses of the reactants equal the sum of the masses of the product. When nucleus of a radioisotope undergoes fission in a nuclear reaction, it loses a tiny amount of masses which is converted or released as energy. So this statement cannot be true. So the answer option B is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 10, JAMB Physics 2018, which goes thus. The graphite rods surrounding the uranium foil rods in the nuclear reactor are used to. Let's go through the options and so we can use that to answer the question. Okay, good. So a reactor grade graphite must be free of neutron absorbing materials. So graphite does not absorb neutrons, and also graphite is not used to control the reaction. So there is no way it will halt the nuclear process, though this answer option is wrong. So let's say the second answer option, create the neutrons and hence start up the nuclear process. Graphite doesn't create the neutron, instead it is the uranium foil rods that creates the neutron by fissioning the uranium atoms. Okay, so it doesn't create the neutrons, neither does it start up the nuclear reaction. So this answer option is wrong. Alright, so answer option C, slow down the neutrons and hence slow the nuclear process. Yes, graphite are used in certain types of reactors to slow neutrons emitted by fissioning uranium atoms so that they are moving at 1 kilometer to 2 kilometer per second. So graphite slow down the neutrons and hence slow the nuclear process. So this is correct. Okay, so let's take a look at the last option, which says speed up the neutrons and hence speed up the nuclear process. This is absolutely the opposite of answer option C, so it is incorrect. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 11, JAMB Physics 2018, which goes thus. When left in the freezer, a bottle full of water cracks on freezing into ice because of the... Okay, first let us take a look at some concept about water. Water is an unusual substance that expands when it freezes. Okay, good. So the effective density of ice is more than that of liquid water. So when water gets solidified to form ice, it is arranged in a tetrahedral open case-like structure geometrically. Okay, so a water molecule forms 4 intermolecular hydrogen bond so that the effective volume increases. Okay, take note of that. Alright, that is to say, anomalous expansion. Okay, and hence the glass bottle filled with water, okay, breaks when water freezes. Okay, so now let's take a look at the answer option. Answer option A says increase in the volume of water. Oh yes, we just said that a water molecule forms 4 intermolecular hydrogen bond so that the effective volume increases. So this answer option is correct, but let's just take a look at the other answer option. Option B, contraction of the bottle. The bottle never contracts. Okay, so this answer option is wrong. Option C, expansion of the bottle. There is no expansion in the volume of the glass bottle. So this answer option is wrong. Then option D says decrease in the volume of water. Rather, the volume of the water increases. Okay, so this is also wrong. So answer option A is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 12, JAMB Physics 2018, which goes thus. The phase difference between waves P and Q in the diagram above is, these two waves are two oscillators that have the same frequency as we can see but different phases. Okay, if they have the same phase, they would have we would definitely be seeing just one line of waves, but this gap between the two waves means that they are out of phase with each other, and the amount of such out of phase is what the question wants us to calculate, and this can be expressed either in degrees or radian. And from the options given, it shows that we are going to measure this in radian, but let us just go through the two so that we can understand better. So it is measured in degrees from 0 to 360. So we have 90, the next is 180, followed by 270 before we get to 360 degrees. Okay, good. So then the equivalent of the radian is, at 0 is 0, at 90 it is pi over 2, at 180 it is pi, At 270, it is 3 pi over 2. At 360, it is 2 pi. In fact, I'm just mentioning that so that you can understand this is radian. Okay, good. So now if we go to look at the phase, the wave P, where did it started from? First, let us just analyze this, the degrees or the radian. Okay, so from 0 up to the crest here, it is 90 degrees, and this is the equivalent in radians. Okay, then at this point it is 180 degrees. This is the equivalent. At this point it is 270 degrees. This is the equivalent. Then at this point it is 360. That is when it makes the complete revolution. Okay, so this is the equivalent. So looking at the waves P and Q, let's assume that they are in the same phase. That means we won't see double waves line like this. We're going to see just one single line. So this is before 90. So it is half of 90. So one wave is ahead of the other half of 90. That is, let's put that in calculation. Okay, half of 90, this is 90, so we want to divide it. That is divided by half. Okay, all right. So if we solve this further, this is what we have: pi over 2 times 1 over 2, and this will give us pi over 4. So this is the radian difference between, this is the phase difference between the wave P and Q. So let us check the answer option. Answer option C is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 13, JAMB Physics 2018, which goes thus: the change in volume when 450 kilogram of ice is completely melted is. So the change in volume is equal to the difference between the volume of ice and the volume of water. Okay, so first we're going to find the volume of ice. So the volume of ice is equal to the mass of the cube, which were given in the question is 450 kilogram, to be divided by the density of the ice, which is also given in the question as 900. Okay, so if we divide further on, we are going to arrive at 0.5 meter cube. Okay, good. So next we go to find the volume of water. So the volume of water is equal to the mass given in the question, 450 kilogram, the same mass with the ice, to be divided by the density of the water, which is given in the question as 1000. Okay, so if we divide further on, we're going to arrive at 0.45 meter cube. All right, so now we can successfully input this value. Okay, so now the volume, your change in volume is equal to the volume of ice, which we found 0.5, minus the volume of water, which is 0.45. So if we subtract this, we arrive at 0.05 meter cube. All right, good. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi and I'm excited to have you here again. This is question 14, JAM Physics 2018, and the question goes thus. Teapots are often silver coated to prevent heat loss by A. Conduction only. Talking about conduction is talking about the most significant means of heat transfer within a solid or between solid objects. Okay, so this does not apply to a pot being silver coated. All right, so this is not correct. All right, then what about the second option, convection? Convection, this is the transfer of heat from one point to another point by the bulk movement. The bulk movement of the fluid itself. Okay, good. So this also is not applicable to a pot being silver coated. All right, so then the third option, C, convection and conduction, both are not applicable. Now let's look at the last option, radiation. In the case of radiation, the hotter the object, the greater the amount of radiant heat emitted. And so the silver inner lining prevents heat loss through radiation, because the radiant heat will be reflected back into the hot water inside by the silver inner lining. Okay, so option D is the correct answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 15, JAM Physics 2018, and the question goes thus. If a force of 50 newtons stretches a wire from 20 meters to 20.01 meters, what is the amount of force required to stretch the same material from 20 meters to 20.05 meters? Okay, so let us write out some important values. So the original length as given is 20 meters. Then the first new length, okay, we'll see is 20.01 meters. So then we are going to experience that the first increase, okay, which is increase in length, which is equal to the new length, which we have as 20.01 minus the original length, and that will give us 0.01 meters. Okay, good. And next we are to find the second increase in length. So, and we know that the original length, we have that, which is now the new length, which we have as 20. Okay, then the second new length which we have here is 20.05. so if we subtract 20 from 20.05, we have the second new length at 0.05 meters. So now we go to the Hooke's law, which states that force is equal to the constant, the spring constant, times the amount of extension E. So with this, we derive K equals force over the extension. So that is what we're going to apply now. So we have F1, that is the first force over the first extension, equal to F2 over E2. So now we go ahead to substitute the values. So for F1 we have at 50, the first extension here we have 0.01, which is equal to the second force, that is exactly what we're looking for. Okay, then the second extension we have at 0.05. So let me move this up a little bit. So now we can cross multiply, and if we do that, we have F2 equals 50 times 0.05 to be divided by 0.01. And if we punch in a calculator, okay, let us quickly do that so that you see. We have 50 times 0.05, okay, to be divided by 0.01. That gives us 250 Newton. Okay, so this is the amount of force that is required to stretch the same material from 20 meters to 20.05. So the answer, option A, is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi and I'm excited to have you here again. This is question 16, JAMB Physics 2018, which goes thus: which of the above are used for characterizing waves? So if you look at the options, it seems that it's only 3 or 2 of the given concept above that are used for characterizing waves. Okay, so just take note of that. So we already know that, but I want us also to just quickly do a quick and rough diagram depicting the features of a wave. Okay, so I'm going to do that now silently. So this is a quick diagram showing a feature of a wave. Okay, so let us now go through the options. We have option 1, wavelength. Yes, wavelength is the distance adjacent crest measured in meter. Okay, this is measured in meter. So this is used for characterizing waves. All right. The second option, medium of propagation. Medium of propagation is not used for characterizing waves. Okay, in fact, the nature of the wave will determine its medium of propagation. So this is not included in what is used for characterizing waves. Then okay, this is, let's mark this, that is included. Then the third option, wave velocity. Wave velocity has to do with the horizontal speed of a point on the wave as it propagates, and it is measured in distance, that is meter over second. So it is also used in characterizing waves. Alright, the fourth option, frequency. Frequency is the number of complete waves that pass a point in inverse seconds or hertz. So this is also used as for characterizing waves. Then lastly, energy. All waves carry energy. Okay, all waves carry energy, and sometimes this energy could be felt, like an earthquake could shake the whole city. Okay, but nevertheless, wave is a common term for a number of different ways in which energy is transferred, but energy is not used for characterizing waves. Okay, so if we look at the options, let's see which of the option has 1, 3, and 4. So option 1, no. Option 2, no. Option C, yes. So option C is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Kemi. It's good to have you here again. This is question 17, JAMB Physics 2018, which goes thus. A 50-watt electric heater is used to heat a metal block of mass 5 kg. If in 10 minutes a temperature rise of 12 degrees Celsius is achieved, the specific heat capacity of the metal is. First, we assume that all the electrical energy produced is converted to heat energy. So we can write that the electrical energy input or supplied is equal to the heat energy absorbed by the object. Okay, good. So next, the electrical energy supplied, which is the electrical power times the time, okay, is equal to the heat energy absorbed, and that is the mass times the specific heat capacity times the change in temperature. Okay, good. So now going to the question, we can find the values of this given equation. So for the power, we have as 50 watts, so we write 50 times the time, which was given as 10 minutes, and we have to convert the minutes to seconds, so we have 10 times 60. Okay, good. Then for the mass, we're given in the question as 5 kg. Okay, the specific heat, C, that is exactly what we're looking for. Then the change in temperature, which is the rise in temperature given in the question, is 12 degrees. All right, so now we can look for the value of C. Okay, so if we solve for C, we have C equals, we divide both sides by 5 and 12, and that is 60, because this times this will give us 60, and the whole of this 50 times 10, 500 times 60 will give us 3000. Okay, to be divided by 60. Okay, and this will give us a final answer, 500 joules per kilogram per Kelvin. Okay, good. So now the answer option B is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Kemi. I'm excited to have you here again. This is question 18, JAMB Physics 2018, which goes thus. metal rods of length 20 meters each are laid end to end to form a bridge at 25 degrees Celsius. What gap will be provided between consecutive rays for the bridge to withstand 75 degrees Celsius? This brings us to the linear expansivity equation, okay, which is L2, or the new length, minus the original length L1, okay, to be divided by the product of the original length times the change in temperature, okay, or rise in temperature. All right, so now what we are asked to look for is the gap, and the gap implies that the difference between the new length and the original length, that is where we get the gap. So this is what we are looking for. So we can just cross multiply. So we have the gap L2 minus L1 bracket on the left hand side, while on the right hand side we have the linear expansivity, which is given in the question as 2.0 times 10 raised to the power minus 5 times the original length, which were given is what? 20. Good. Times the change in temperature or rise in temperature. The initial temperature was 25, and the later temperature, the expected temperature, which is 75. So 75, okay, let me just 75 minus 25. All right, so if we solve for the one, we have 2.0 times 10 raised to the power minus 5 times 20, okay, then times 75 minus 25, which will give us 50. Okay, good. So if we solve for the run, we have 20 times 50, that gives us 1000. So 1000 times 2.0 will give us 2000, okay, times 10 raised to the power minus 5. And if we are to simplify further, we multiply 2000 by 10 raised to the power minus 5. That means we go to the left, 1, 2, 3, 4, 5. That is 0.02 meters. That is the gap. All right. So if we go to the answer option A is, no, it's not answer option A, sorry. Answer option D is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 19, JAMB Physics 2018, and the question goes thus. Transverse waves can be distinguished from longitudinal waves using the characteristic of, first let's talk about transverse waves. Okay, good. So transverse wave is a moving wave that consists of oscillations occurring perpendicular, that is right angle to the direction of energy transfer or the propagation of the wave. For instance, let me just draw a quick illustration of this wave. It goes like this. Okay, so this is an example of a transverse wave. What about talking about longitudinal waves. These are waves in which the displacement of the medium is in the same direction of propagation of the wave. Okay, this is an example of a longitudinal wave. Okay, good. So now let's go to the options to look at the particular characteristic that is associated with transverse wave that distinguished it from the longitudinal waves. Okay, good. So option A says diffraction. Option A, diffraction. Option B, refraction. Option C, polarization. Yes, polarization is a property applying to transverse wave that specifies the geometrical orientation of the oscillations. Okay, so this is how the polarization of a wave looks like. Okay, so the answer option C is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 20, JAMB Physics 2018, which goes thus. A man exerts a pressure of 2.8 times 10 raised to the power 3 Newton meter square on the ground and has 4 times 10 raised to the power minus 2 meters square of his feet in contact with the ground. The weight of the man in question is the force of the man. Okay, so and this brings us to the equation, which is the formula of pressure equals force over area. Okay, so since we are looking for force, we make that the subject of the formula, which means pressure times area, and pressure times area is equal to pressure we're given in the question as 2.8 times 10 raised to the power 3 times the area, which also is given in the question as 4 times 10 raised to the power minus 2. So if we now punch in our calculator 2.8 times 10 raised to the power 3, which is going to be, that means that 2800, okay, because the dot we go 1 2 3, okay, times the minus 10 raised to the power minus 2, which means that the decimal point we go 1 2, that is times 0.04, okay, and that will give us 112 Newton. Okay, so this is the weight of the man. So the answer option D is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi and this is question 21, Physics JAMB Physics 2018, which goes thus. From the statement above, the qualities of a good thermometer are, so let's observe the statement above. The first statement, high thermal capacity. For a high thermal capacity thermometer means that high amount of heat will be required to raise the temperature of the substance in the thermometer by 1 degree. Okay, so the thermometer will only work when the heat of the body is very high. So this is not a good quality of a good thermometer. Okay, the second statement, high sensitivity. A thermometer with a high sensitivity with a quality of high sensitivity means that even little amount of temperature difference can be detected and observed. Okay, so this is a good quality. All right, the third quality, easy readability. Of course, the thermometer, that is mostly the glass thermometer, should be eligible. Okay, the readings should be eligible. All right, good. So this is also a good quality. This is also a quality of a good thermometer. Then the fourth statement, accuracy over wide range of temperature. Of course, this is also needed for a good thermometer, whereby the thermometer can record a low temperature and also record a high temperature. Okay, so from the statement above, the qualities of the thermometer includes 2, 3, and 4. Okay, so the answer option D is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 22, JAMB Physics 2018, which goes thus. A machine is used to lift a load of 20 Newton through a height of 10 meters. If the efficiency of the machine is 40%, how much work is done? We can find this out from the formula of the efficiency of the machine equal to the work output over work input times 100. Okay, so from the question we already have some of the values. Okay, for instance, the efficiency of the machine is 40%, so we have 40 equals to the work output, which is the force times distance, which we have in the question, is 20 times 10. Okay, to be divided by the work input, which is what we're looking for, the work done. Okay, so let's x represent that, then times 100. Okay, so if we simplify further, so and cross multiply at the same time, so we're going to have 40x on the left hand side, then on the right hand side 20 times 10 times 100 will give us 20,000. Okay, so we go ahead to divide both sides of the equation by 40 in order to find the work input x. So we start crossing out, then 40 in 20,000 will give us 500 joules. Okay, so that is the work input. So if we go to the answer option D is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm so excited to have you here again. This is question 23, JAMB Physics 2018, which goes thus. Which of the following could be effectively used to reduce friction? Friction, as we know, is a force that is resisting the relative motion of solid surfaces, fluid layers sometimes, and also material elements sliding against each other. So a common way to effectively reduce friction is by using lubricant such as oil, grease. Okay, all right, so let's take a look at the options. Option A says water. Water could also be used to reduce friction, but not as effective as oil or grease. Okay, so in this case water is not the correct answer. Okay, option B, petrol. Petrol cannot be used to reduce friction. Okay, or probably effectively used to reduce friction. All right, good. Likewise, kerosene cannot be used or cannot effectively reduce friction. Then option D, yes, grease is one of the common ways to effectively reduce friction. All right, because it is a perfect lubricant. All right, so the answer option D is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 24, JAMB Physics 2018, which goes thus. A copper wire was subjected to a tensile stress of 7.7 times 10 raised to the power 7 Newton per meter square. Calculate the tensile strain of the wire. And this brings us to the formula for calculating the Young modulus, which is equal to the tensile stress over the tensile strain. Okay, and already we have the values given, some values given in the question. Like for the Young module, we have 1 times 1.1 times 10 raised to power 11, which is equal to the stress, which is also given, the value is given in the question, which is 7.7 times 10 raised to power 7. Okay, it is the value of the strain that we are asked to calculate. All right, so by the time we cross multiply in order to look for the value of the strain, we're going to have 7.7 times 10 raised to power 7 to be divided by 1.1 times 10 raised to power 11. Okay, so if we divide 7.7 by 1.1, so let us use the calculator quickly. 7.7 divided by 1.1, so that gives us 7. So we have 7. Then for the 10 raised to power 7 divided by 10 raised to power 11, we'll be left with 10 raised to power, that is 7 divided by 10 raised to power 4, and which is also equal, which is same as 7 times 10 raised to power minus 4. Okay, so the tensile strain is 7 times 10 raised to power minus 4 Newton per meter square. So this is our final answer. So the answer option A is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 25, JAMB Physics 2018, which goes thus. An object weighs 22 kg in water and 30 kg in air. What is the upthrust exerted by the liquid on the object? So this brings us to the formula for finding the upthrust, which is equal to the weight in air minus weight in liquid. Okay, and so the weight in air, which is equal to mass times gravity, okay, minus the weight in liquid, which is also mass times the gravity in water. Okay, and this is going to be equal to the mass times gravity. The mass of the object in air is 30 times the gravity 10 minus the mass of the object in the water, which is 22 times the gravity 10. Okay, so now we have 30 times 10, that gives us 300, minus 22 times 10, which gives us 220, and this gives us the final answer, 80 Newton. So the upthrust is equal to 80 Newton. So the answer option B is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 26, JAMB Physics 2018, which goes thus. A block of aluminium is heated electrically by a 30-watt heater. If the temperature rises by 10 degrees Celsius in 5 minutes, the heat capacity of the aluminium is. So this brings us to the formula. Heat supplied is equal to the heat gained. All right, and the heat supplied is the power times time, okay, which is equal to the heat gain, and heat gain is MC times the change in temperature. Okay, and at this junction we need to note that MC is equal to heat capacity. Okay, so and the heat capacity is what we're looking for. All right, so we now have the heat capacity MC is equal to the PT over the change or rise in temperature. All right, so now we have the power which as given in the question, which is 30, okay, times the time it took, which is 5 minutes, and we have to convert the minutes to seconds, so we multiply by 60 to be divided by the temperature rise, which is 10. All right, so by the time we simplify further, 0 cancels 0, so 30 times 5 times 6, so this will give us 900 joules per Kelvin. Okay, good. So that is the heat capacity. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 27, Physics JAMB 2018, which goes thus. A perfect emitter or absorber of radiant energy is A. We're given the following options to choose from. But first, let us go through some concepts. So objects that are good emitters are also good absorbers. Okay, and this is a law that is stated as or known as the Kirchhoff radiation law. Okay, so for a blackened surface is an excellent emitter as well as an excellent absorber. Okay, but if this same surface is silvered, it becomes a poor emitter and a poor absorber. So a black body is one that absorbs all the radiant energy that falls on it. Okay, good. So let's go back to the question. A perfect emitter or absorber of radiant energy, which happens that if we have a perfect emitter, it's also a perfect absorber, okay, is A, white body? No. B, red body? No. C, conductor? No. D, black body? Yes. A black body is one that absorbs all the radiant energy that falls on it. So the answer option D is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm so excited to have you here again. This is question 28, JAMB Physics 2018, which goes thus. The phenomenon that shows that increase in pressure lowers the melting point can be observed in A. Sublimation. Sublimation is the transition of a substance directly from the solid state to the gas phase without passing through the intermediate liquid state. Okay, so this does not correspond with this phenomenon. All right, good. So now let's go to the next option. Condensation. This is the process by which water vapor in the air change into liquid water. Okay, this also does not have anything to do with this phenomenon given in the question. Okay, so we go to the third option, coagulation. Coagulation, also known as clothing, is the process by which blood changes from liquid to a gel, forming blood clot. Okay, so this also does not correspond with this phenomenon given in the question. So now let us check the last option, regulation. This is a process of generation of melt water from ice, which is subject to high pressure or to higher pressure. Okay, that is to say, the higher pressure of ice mass lowers, let me rewrite that, lowers the melting point and causes the ice to melt. Okay, so we can see that radiation is a phenomenon that shows that increase in pressure lowers the melting point. So the answer option D is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm so excited to have you here again. This is question 29, JAMB Physics 2018, and the question goes thus. If the volume of a gas increases steadily as the temperature decreases at constant pressure, the gas obeys. So first, what the question is saying is that as the volume increases, the temperature decreases, which means that the volume is indirectly proportional to the temperature at constant pressure. Okay, that will be P. Alright, so let us now go to the options to see which one of this law correspond with this principle. Okay, so the first option, Graham's law. Okay, Graham's law states that the rate at which gas diffuse, okay, the rate at which gas diffuse is inversely proportional to the square root of their density. Okay, so this does not tally with this. Alright, so we go to the next law, which is Boyce Law. Boyce Law states that at constant temperature, the volume of a given mass of gas is inversely, okay, proportional to its pressure. Okay, remember, at constant temperature. Alright, so this also does not tally with this. Okay, what about the C option, pressure law? Pressure law, also known as Gay-Lussac's law, is one of the gas law which states that for a fixed mass of gas at constant volume, pressure is directly proportional to the absolute temperature. Remember, at constant volume. Okay, so this also does not correspond with this gas law. Okay, so let us try the last law, which is Charles law. And Charles law states that the volume of a gas is directly proportional to the temperature provided pressure is constant. Okay, so if we look at these four given laws, there is none that tallies with the law stated in the question. So none of these options are correct. Okay, thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 30, JAMB Physics 2018, and the question goes thus. Steam burn is more severe than that of boiling water because, let us understand this fact that steam will produce more severe burns than boiling water because steam has more heat energy than water due to its latent heat of vaporization. Okay, this latent heat of vaporization is the amount of heat required to convert unit mass of liquid into vapor state without change in temperature. Okay, so let's go back to the question. Steam burn is more severe than that of boiling water because A. Steam burn is independent of relative humidity. No. B. Steam possesses greater heat energy per unit mass. Exactly what we just said now. Alright, so the answer option B is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 31, JAMB Physics 2018, and the question goes thus. A satellite moves in a circular orbit of radius 4r around the Earth. The acceleration of the satellite in terms of g is. There is a formula for the acceleration of the satellite, which is a equals gm over r squared. The g is the gravitational constant, okay, while the m is the mass of the central body which the satellite orbits. Okay, then the r is the radius of orbit for the satellite. Okay, so we were given in the question that the radius is 4r, so let us impute that. So we have gm over 4r squared. Okay, so now we have gm over 4 times 4, or 4 squared is 16, then r squared. Alright, then we need to remember that g is equal to gm over r squared. Okay, and that would bring us to splitting this up. So we're going to have gm r squared times 1 over 16. Okay, good. So now this is what we're going to have. So this is going to represent g. So we have g times 1 over 16 will give us g over 16. So this is acceleration in terms of g. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Oluwakemi. I'm glad to have you here again. This is question 32, JAMB Physics 2018. And the question goes thus. In the diagram above, the direction of the force between north and south in the magnetic field is. First, I would like us to pay attention to some key important features that this diagram shows that this diagram depicts. Okay, so the first one is that the magnetic field lines never cross each other. Okay, so we can see the magnetic field lines that never crossed each other. All right, good. The next is that the closer the lines, the stronger the magnetic field. The closer the lines, the stronger the magnetic field. Alright, good. Then the third observation is that the lines have arrow heads. Okay, to show the direction of the force exerted by a magnetic north pole. Okay, good. It shows the direction of the force exerted by a magnetic north pole. As you can see that the lines have arrowheads showing this. Okay, then fourthly, we also note that these arrowheads point from the North Pole to the South Pole. Okay, good. So now let's go to the question. Alright, so in the diagram above, the direction of the force between North and South in the magnetic field is option A, MP. I don't know what that means. Okay, so this is wrong. Option B, South North, not at all. Option C, North South, exactly. Okay, the arrowheads point from the North Pole of the magnet to its South Pole, showing the direction of the force exerted by the North Pole. Alright, so option C is correct. Thank you for watching. See you in the next video. Bye bye. Hi, I am Kemi. I'm glad to have you here again. This is question 33, JAMB Physics 2018, and the question goes thus. At what frequency would a 10 Harris inductor has a reactance of 2000 ohms? There is this formula for finding inductive reactance, which is equal to 2 pi f frequency and L inductance. So we are looking for the frequency, so we're gonna make frequency the subject of the formula. So we have XL over 2 pi L, and then the question, we already given some values. We have the reactance, which is given as 2000 ohms over 2 times. We are calculating or working in terms of pi, so we're not going to change that value. Then for the inductance, we're given 10 Harris. So now we go ahead to cross out. 0 we cancel 0, 2 into 1, 2 into 100 is 100. So we are left with 100 over pi hertz. Okay, so this is the value of frequency. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Kemi. I'm excited to have you here again. This is question 34, JAMB Physics 2018, and the question goes thus. What force has to be exerted on the mass 60 kg to give it an acceleration of 10 meters per second square vertically upward? Okay, the force that has to be exerted, F, is equal to the upward force, which is mass times acceleration plus the gravitational force, which is mass times gravity. Okay, so now we substitute the different values. For the mass, we were given is 60 kg, so we have 60 times the acceleration as given on the question, which is 10 meter per second square. Okay, good. Then in the gravitational force, the mass which still remain the same, which is 60, then plus the gravity as given in the question, which is 10. Okay, so now we go ahead to solve. 60 times 10, that gives us 600, plus 60 times 10 again, which gives us 600. So finally we have force equals 1200 Newton. So this is the amount of force that will be exerted on the mass to give it this acceleration vertically upward. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 35, JAMB Physics 2018, which goes thus. A satellite revolving around the Earth is kept on its orbit by... First, let's take a look at the concept surrounding this. Okay, good. So, some people confuse centrifugal force with its counterpart, centripetal force, because they are closely related, and one might say that they are two sides of the same coin. So first, let's talk about the centrifugal force. This is defined as the apparent force that is equal and opposite to the centripetal force, drawing a rotating body away from the center of rotation caused by the inertia of the body. Okay? Why centripetal force is defined as the component of force that is acting on the body in a curvilinear motion that is directed toward the center of curvature or axis of rotation. However, note that the centripetal force is an actual force, while the centrifugal force is defined as the apparent force. So both of these forces are working to keep the satellite revolving around the Earth. So both of these forces are working together to keep the satellite that is revolving around the Earth kept in its orbit. Okay, so let us take a look at the answer options. Option A says centrifugal forces only, not correct. Option B, centripetal forces only, not correct. Option C, centripetal and frictional forces, not correct. Option D, centripetal and centrifugal forces. Yes, this is correct. So answer option D is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 36, JAM Physics 2018, which goes thus. The plates of a 0.5 microfarad uncharged capacitor are connected to a 10-volt battery. The charge on the capacitor after a long time is. So there is a simple formula for solving this question, which is Q equals CV. The Q is charge in coulomb, while the C is the capacitance in farads. Then the V, which is the volt in volts. The voltage in volts. Okay, good. So we already have some of these values in the question. Okay, so Q, which is unknown, then for the capacitance, which is measured in farads, we have as 0.5, okay, times the volt, which is given on the question. The volt of the battery is 10. All right, so by the time we multiply these, we have a final answer as 5 microcoulomb. Okay, good. So this is our final answer. So the answer option D is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm so excited to have you here again. This is question 37, JAM Physics 2018, and the question goes thus. If a document is to be produced using a duplicating camera, where should the document be placed in order to obtain an exact copy? Okay, the lenses of a camera is a convex lens. Okay, so we're going to make use of a quick diagram that would help us to illustrate this. Okay, all right, so now I want to draw the lens, and now be that perfect just for illustration. Okay, so this is the center, this is F, and this is 2F. Okay, then on the image size we also have F, and we also have 2F. So when the image is located at 2F, say this is an image, okay, at 2F point, the image will also be located at 2F point on the other side of the lens. In this case, the image is upside down image. Okay, the dimensions are equal. Okay, the dimensions in terms of the height are both inside and outside of the lens, they are the same. The dimensions are equal to the object's dimensions. Okay, so if the object is 5 inches, the image too will be 5 inches. Okay, good. That is to say that the absolute value of magnification is exactly 1. Okay, so if the object is 5 inches, the image too will be 5 inches. Alright, so now let us go back to the question. Alright, So the answer options, we have answer option A are the point which is twice the focal length of the lens of the camera. Exactly. This option is correct. Are the point which is twice the focal length, that is 2f. Okay, that is when we can have the document to produce or obtain the exact copy, that is of the same dimension. All right, good. So answer option A is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 38, JAM Physics 2018, and the question goes thus. The efficiency of a machine is 70%. Calculate the work done using this machine to raise a load of 10 kg through a vertical height of 2.0 meters. Okay, there is this simple formula for calculating the efficiency of a machine, which is N equals to energy output over energy input, okay, times 100. All right, so now let us simplify further. The N is efficiency of the machine, which we already have. We're given as 70, so let's substitute that in immediately. Then for the energy output, which is, okay, let me write that out, mgh, that is mass times gravity times height, okay, over the energy input. Let us just represent that with EI, okay, times 100. All right, so now let us substitute the values for mgh. So we have 70 equals the mass we're given, which is 10 kg. So 10 times the gravity, which is also given in the question as 10. Okay, then times the height, which is given as 2.0, to be divided by energy input, then multiplied by 100. Okay, so now let us make EI the subject of the formula. So if we cross multiply, we have EI, that is the energy input, equals 10 times 10 times 2 times 100 will give us 20,000. So it is 20,000 to be divided by 70. Okay, and this will give it, let us quickly use our calculator to do that. So if we have 20,000 to be divided by 70, we have 285.71. okay, 285.71 joules. That is the energy input. Okay, so if we check the answer, there is no appropriate answer in the given option, but this is the correct answer. Okay, thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm so excited to have you here again. This is question 39, JAM Physics 2018, which goes thus. Which of the following statement is not true about atoms? So we're going to go through the options to verify which one is incorrect. So option A, atoms of different elements have different atomic weights. Of course, each element have unique properties. Okay, they all have unique properties in terms of different atomic numbers, so this will also affect the atomic weight, making it to be different from each other. So this is correct. Okay, the next option, the mass of an atom is concentrated in the nucleus. This also is correct because the mass of an electron is very small compared to proton or neutron. And since nucleus contains proton and neutron, most of the mass of an atom is concentrated in the nucleus. Okay, so this is correct. Option C. An atom is made up of nucleus and a number of electrons. This also is absolutely correct. In the nucleus, you'll find the proton and the neutrons, okay? And you will also find the electron, okay, the outermost shell. So these are the three particles that made up an atom. So this also is correct. What about the last option? Atoms of all elements are identical. Atoms of all elements are not identical. In fact, the number of protons in an atom is a defining feature of an atom. It makes an element different from another element. Okay, so the number of proton in an atom is also called the atomic number. Okay, so answer option D is not a true statement about atoms. So this is the correct answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Kemi. I'm excited to have you here again. This is question 40, JAMB Physics 2018, and the question goes thus. A current of 20 amps flows through a cable whose resistance is 5 ohms. Calculate the electric power dissipated. This is a very straightforward calculation with a simple formula, which is P, the electrical power, is equal to the square of the current times the resistance measured in ohms. Okay, so already we're given the value of the current, which is 20 amps. So we input the value, which is 20 square, okay, times the value of the resistance, which is given as 5 ohms. All right, so now we simplify further. So 20 square will give us 400 times 5, and this will give us a final answer of 2000 watts. Okay, good. Then let's check the answer. The answer option A, 2 times 10 raised to power 3, is the same as 2000 watts. Okay, so the answer option A is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Kemi. I'm excited to have you here again. This is question for the one JAMB Physics 2018, which goes thus. The dimension of electromotive force are. The formula for finding electromotive force is E, which is electromotive, equals to work done over, that is W, over charge. Okay, but we're going to break this down. All right, so let's start with the work done. The work done is equal to force times distance or displacement, as we know. All right, so we break the force further down. The force, remember, is mass times acceleration. Okay, Then we still bring down the D. We're going to change all this into dimension as we go on. All right. Then for the mass, the dimension for mass is A. Then for acceleration will still be broken down. Remember that acceleration is, the unit for acceleration is meter per second square. Okay, so the meter will be represented in dimension with L. Okay, while the seconds, that is, the unit seconds will be represented by T in dimension. So we have T minus, as in T raised to the power minus 2, okay, times the dimension for displacement is L. All right, good. So if we look further, we can also see that we can still multiply through by L. So we have M L square T raised to the power minus 2. So we're going to use this, we're going to input that as a dimension for work in there. But before then, let us also solve for the dimension, or let us also figure out the dimension for charge. Okay, and remember that the dimension for charge, which is Q, is equal to current measured in, which is equal to current I times time, okay, T. So that is the dimension for this. Then we're now going to input that in the dimension for electromotive force. Okay, so now we have E equals, we represent, this will represent W, so we have the dimension ml square T minus 2 over, now this is the dimension for Q, that is IT. Okay, good. So now we need to simplify further. Okay, so the T raised to the power minus 2 will come down to the denominator, so we have ml square over IT times the T square. That is the one that came from the numerator. Okay, so we now have our final answer. Maybe not a final answer, but we're approaching the final answer. Okay, so we multiply through by T squared, so we have IT raised to the power 3. All right, then finally we're coming to the final end. So now we have ml square. We need to bring the denominator up. Okay, so to that effect, I will be raised to power 1, then the T will be raised to power minus 3. So this is the dimension for electromotive force. So let's go to the answer option. Answer option B. Okay, answer option B is the right answer. It's just that the T is at the end there, while the T is at the middle here. So answer option B is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Oluwakemi, and I'm excited to have you here again. This is question for the 2 JAMB Physics 2018, and the question goes thus: which of the above are the correct SI unit of the quantities indicated? The first quantity indicated here is force with the SI unit N. Yes, the SI unit of force is Newton. This is correct. The second quantity, torque. The SI unit given here is Newton per meter. This is wrong. The SI unit for torque is Newton meter. Okay, so this is wrong. Alright, then the third quantity, current. The SI unit given there is ampere, and this is correct because the SI unit of current is ampere. Then the last quantity given, power. The SI unit of power is watt, and this is what as it is represented here. Good. So the quantities with the appropriate SI unit are 1, 3, and 4. So let's check the answer option. For A says 1 and 2, no. B says 1 and 3, no. C says 1, 2, 3, no. Then D says 1, 3, and 4. Yes, this is correct. So the answer option D is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Kemi. I'm excited to have you here again. This is question for the 3 JAMB Physics 2018, and the question goes thus. The resultant of two forces, 2 Newton and 5 Newton, is 13 Newton. What is the angle between the two forces? We're talking about the two forces 12N and 5N. Okay, so let us quickly take a quick look. We don't know if the angle between the two forces, we don't know what the angle is, so that's what we want to find out. Okay, good. So this is the resultant. So this is 12N and this is 5N, while this is 13N. So we have to find this angle right here. Okay, so merely looking at this triangle, this reminds us of the Pythagoras Theorem. Okay, so and remember what this theorem says. This theorem said that the square of the hypotenuse, in this case which is 13, is equal to the addition of the two other sides of the addition of the square of the two other sides of the triangle, which is what we have here. Okay, so if we simplify further on, 13 square will give us 169. Okay, then 12 square is 144, then 5 square is 25. So finally we have 169 equals 169. So if we have a triangle and it shows that the Pythagoras theorem applies to that triangle, it means that the angle between these two forces is 90 degrees. Okay, good. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Kemi. I'm excited to have you here again. This is question 44 JAMB Physics 2018, which goes thus. Which of the following is not a vector quantity? A vector quantity is a quantity that has both magnitude and direction. And there are quite a number of examples, but it seems the option already has 3 of these. So let us check out which ones are vector quantity and which one is not a vector quantity. Okay, so option A says altitude. Altitude has only to do with magnitude but has no direction. So altitude is not a vector quantity, but let's go through the other options to confirm. Option B, acceleration. Acceleration has both magnitude and direction, so it is a vector quantity. Alright, displacement also has magnitude and direction, so it is also a vector quantity. Then the last option, weight. Weight also has magnitude and direction, so it's also a vector quantity. So the quantity here that is not a vector quantity is altitude. So answer option A is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question for the 5 JAMB Physics 2018, and the question goes thus. A force F is required to keep a 5 kg mass moving around a circle of radius 3.5 meter at a speed of 7 meter per second. What is the speed if the force is tripled? Okay, from Newton's second law, force is equal to ma, okay, and the acceleration here is the centripetal acceleration, okay, which has its own formula. A equals v squared over r. The v is the velocity, while the r, this is the velocity, while the r is the radius of the circle, okay, measured in meters. All right, so we're going to substitute this equation for A in the formula F equals ma. So now we have mv squared over r, and this equation is the equation for the centripetal force. Okay, so now let us solve for the first. Let me do it on this side. So F equals m, the mass we're given is 5, okay, times the velocity, that is the speed, which is equal to 7. So now we have 7 squared over the radius, which is given as 3.5. Okay, so 5 times 7 squared, 7 squared is 49, so we have 245 to be divided by 3.5, and if we punch that into our calculator, we have the force equal to 70 Newton. Okay, all right, then if we go to the question is what is the speed if this force is tripled? Okay, if the force is tripled, we're talking about 3 times F, okay, and we're still talking about the centripetal force. So let us just substitute the F in there. So we have 3 times 70 equals, the mass still remains 5 kg, then times the speed, which is what we are looking for now. It is unknown when the force was tripled. Okay, so we see have the radius as 3.5. So if we cross multiply now, we have v squared equals 3 times 70. Let us just put it to 10. 3 times 70 is 210, then times 3.5 to be divided by 5, and this will give us 147 if you punch that on your calculator. So if we square both sides of the equation, let me just move this slightly up. So we now have v equals the square root of 147. Let us bring out our calculator this time around. Okay, so the square root of 147 is 12.1 to 1 decimal place. So we have 12.1 meter per second. So that is the speed when the force was tripled. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hello, I'm Oluwakemi. I'm excited to have you here again. This is question for the 6th JAMB Physics 2018, and the question goes thus. if a wheel 1.2 meter in diameter rotates at 1 revolution per second, calculate the velocity of the wheel. The velocity of the wheel V is equal to, it has its own formula, the angular velocity W times the radius of the wheel. Okay, and also note that in another instance the angular velocity W is equal to 2 pi over time. The 2 pi is the radian, which is the complete revolution per time. Okay, good. So now we're going to substitute this for the angular velocity in this equation. Okay, so now we have V equals 2 pi t times r, and we shall go ahead to put in the various values. Okay, so 2 times pi is 22 over 7, then the t, which is the time taken to complete one revolution. Okay, so that will be 1, so that is not included. All right, so now times the radius, and the radius is half of the diameter. The diameter given here is 1.2, so if we divide that by 2 we have 0.6. okay, so now if we punch the calculator, let's use a calculator. Let's quickly use that. So we have the calculator to do this. We say 22 times 2 times 0.6, okay, to be divided by 7. All right, so we arrive at 3.77 meter per second. That is the velocity of the wheel. Okay, so the answer option B is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 47, JAMB Physics 2018, which goes thus. A body of mass 4 kg resting on a smooth horizontal plane is simultaneously acted upon by two perpendicular forces, 6 Newton and 8 Newton. Calculate the acceleration of the motion. Let us have a quick diagram of what this question is about. So this is the horizontal plane, and let's say this is the body, and we said the body is 4 kg. Okay, then there is these two perpendicular forces acting on it. Let's say this is 6 Newton, and another one the horizontal, which is 8 Newton. Okay, and with this, only the resultant of the perpendicular forces, which is this, is acting on the body. So let's say that is F. And so to find this perpendicular, and so to find this resultant force, okay, which is the hypotenuse, and that is F equals to, according to the Pythagoras Theorem, we have the square root of 6 square plus 8 square. Okay, so now we have F equals the square root of 6 square is 36, so we have 36, plus 8 square is 64, and this will give us 100, so the square root of 100 is 10. So the resultant force is equal to 10 Newton. So now that we know the resultant force, we can find the acceleration, and you know that force is equal to mass times acceleration. Okay, so now A is equal to force over mass, and the force we found is 10 divided by the mass, which is 4, and this will give us 2.5 meter per second square. Okay, so the answer option A is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Kemi. I'm so excited to meet you here again. This is question 48, JAMB Physics 2018, which goes thus. The diagram above shows a Planck RS pivoted its center of gravity O and is in equilibrium with the weight P and Q. If a weight 2P is added to P, the Planck will be in equilibrium again by. So let us take a look at this diagram. We were told at the initial stage, this where the Planck was at equilibrium. Okay, looking very closely at this diagram, it seems like the distance of the weight P from the center of the pivot is the same as the distance of Q away from the pivot. That is what it seems. So if that is the case, it seems that the weights are the same. The weight of P is equal to the weight of Q. Okay, so then the second instance is that a weight 2P is added to P. That means more weight is added to P. So in that case, we know that we're going to have a clockwise moment. And when a body is in equilibrium, the anti-clockwise moment is equal to the clockwise moment. Okay, good. So now how do we balance this up? So naturally or logically, you will see the Planck is going to fall clockwise, sorry, anti-clockwise. Okay, and this will go clockwise, anti-clockwise as well. So how do we balance this up? We will need to shift this weight closer to the pivot. Okay, and in another case we may have to shift the Q farther away from the pivot. Okay, so it is either in those instances we either shift the weight, the extra weight of the P towards the pivot, or we shift the weight of the Q away from the pivot, farther away from the pivot. So let us look at the option to see which one might fit into our description. Option A says moving Q nearer to O. Moving Q nearer to O? No. In fact, that will even make it to be more unbalanced. Okay, so option A is not correct. All right, option B, moving P nearer to O, that is the pivot, exactly what we said, because P is now more weighted, so it will need to move closer to the pivot in order to maintain equilibrium. Okay, so the answer option B is the answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm so excited to have you here again. This is question 49, JAMB Physics 2018, and the question goes thus. Which of the above conditions must hold for a body acted upon by a system of three coplanar forces in equilibrium? For forces to be in equilibrium, it means that they are balanced. Okay? And coplanar force systems have all the forces acting in one plane. Okay? So I would like us to quickly go through a summary of the characteristics of a coplanar force system. One is that the lines of action are coplanar. That is, they are in the same plane. Alright? Good. What about the other characteristics? Another one is that the lines of actions are convergent. That is, they intersect at a common point. Alright? Then lastly, the third point that I want to look at is that the vector sum of these forces is equal to 0 vector. Okay, good. So now let's go to look at the conditions given in the question. All the three forces must be concurrent. Of course, all the three forces must be concurrent, which means that the lines of action are convergent, and that which means that they intersect at a common point. Okay, good. So this condition is favorable. Alright, the second condition, the upward force is equal to the downward force. This does not correspond to the characteristics of a coplanar force system. Okay, then the third condition, the algebraic sum of the moment about any point must be 0. Of course, we just highlighted that the vector sum of all these forces is equal to 0 vector. So this condition is also correct. So we have condition 1 and 3 correct. So let us look at the option. Option B is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hello, I'm Oluwakemi. I'm glad to have you here again. This is question 50, JAMB Physics 2018, which goes thus. What is the frequency of vibration if the balance wheel of a wristwatch makes 90 revolutions in 25 seconds? The frequency of revolution is the number of revolution in a unit time. Okay, good. And so frequency is equal to 1 divided by the period which is required to complete 1 revolution. Okay, and also take note that the SI unit for frequency is hertz. Okay, that is Hz. Alright, good. So now let us calculate the frequency of revolution when we have 90 revolutions. Remember, the one which is the number of revolutions, now we have 90 revolutions, okay, over the period. What time does it take to run this? It takes 25 seconds, okay. So now we want to divide 90 by 25. So 90 divided by 25, this will give us 3.6 hertz. So this is 3.6 hertz. Alright, so the answer option D is the right answer. Thank you for watching. See you in the next video. Bye bye.